So after we built the socially emotional robot on the other side that we saw named It, we were thinking, how do we use that technology? What do we do with that? Well, the next place to go was toys. Again, we always build that prototype first. And so our prototype for a toy doll is little baby Bit. Well, baby Bit's face comes off just so we can show you where all the gears are and how that all works. We would never sell anything that looks quite like that. But we partnered up with Hasbro. Hasbro makes a lot of the toys and they knew how to do that industry. And we provided the technology for My Real Baby. My Real Baby comes out of the box, a brand new little baby, and she has sensors all over her body. And so as I interact with the doll, she's able to grow and change, and she can make noises and speak. So if I turn her on, you can see how happy she is. And then what's really cool is she has sensors in her mouth. And so when I feed her her bottle, she knows the bottle's there. She says, wants more. And so the baby gets really excited about having the bottle and grows with the child. And this was really fun, but of course not every child's going to want a toy doll. And so we had to think about what other toys could we develop. And so we started to work on a toy here called Meeps. And Meeps are adorable. They have hearing sensors on either side of their eyeballs, and they react to the tone of your voice. So if you call your Meep, it comes running to you. If you yell at your Meep, it runs away. And this was a really fun toy, but we were a young company, and other than partnering with Hasbro, we'd never made mass-manufactured toys before or any mass-manufactured anything. We were really good at 1, 2 robots, prototypes. This was a whole different industry. And it turned out that the robot was too expensive to manufacture. Now, it was something that we'd never thought of before, but we've never forgotten here either, is that the robot cost impacts how much the robot will sell for, and we had to think about that stuff. So little Meep had to go back on the shelf. We never sold it. And for a lot of people, that's a failure. We don't consider anything like that a failure. It's a learning process. And all of the things that we design and all of the things that we learn as we're designing, they keep following. They keep inspiring that next robot that we build. Now for Meeps, clearly not a failure, because if you look at the bottom of a Meep, lo and behold, you have a round robot, 2 wheels, a little caster wheel, and that might actually look a lot like that very big robot that we all know, Roomba. So later when we get to Roomba, we'll see how that shape and design comes back. But the little Meep that we didn't sell and went back on the shelf, that design inspires where we went with Roomba. So the toys were great, but we knew we had to move on. We were going to do other things with our knowledge. And so in the background, we were still doing a lot of research. Research was something that always guided that next innovation. Some of the research we were working on were robots like this. They're squishy, they're movable. And so the robot can actually morph itself into different shapes by moving the air in and out of the robot. This was one thing we thought about, and then we thought, well, how do you practically apply that? That application became a gripper. This could be a hand for a robot. Again, you've got a soft top. This is actually filled with coffee grounds, right? Think about those K-cups that you buy for your coffee maker. All the air is extracted. They become very hard. Well, if I extract the air out of the robot, it becomes a gripper, and it can grip really strongly. So that was another idea that we had. Of course, grippers can take many different shapes. At one point, we were working on an arm. Same theory, we could use the air and the tension in the hand to make the hand move. That was fairly realistic. It looks a lot like a spacesuit, and actually it was kind of fun to see some of our top engineers using a sewing machine to put the hand back together. You never know what skill you're going to need in STEM. But we made other grippers as well. This particular one is manufactured, and again, we can move the arm and the fingers to start making different kinds of grippers. So all of this knowledge allowed us to try a lot of different industries, a lot of different robots. Some of the older robots you see up here, swarm robots, they work together. This guy was a data bubble. It actually sank to the bottom of the ocean and would gather data and come back up. But again, we had to think about what's the practical application? How are we going to use these robots to change the world, really make a difference, and help people? Early in our history, we were also exploring underwater technology. It was kind of part of the research we were doing, but again, folding into the robotics we wanted to develop. Sea Glider is one of the robots that came out of that, and what makes it really cool is that it was a partnership with a university. The university has continued the work even though we're no longer working underwater. The robot itself is a glider. So it has very little power, it has enough energy to get itself down to the bottom of the ocean, and then it actually glides along the current, much like a dolphin. It's shifting weight from nose to tail with an oil bladder. So as it drives along, it's gathering data. That data might be salinity of the water, it might be temperature, it might be depth. Once the robot has gathered enough information, it pops up, and with its antenna, we're able to gather that data back. While the robot's working, we can only track it, we kind of know where it is, but we can't read that data at that time. So how would you use a robot like this other than information about the water? Well, when the Gulf of Mexico oil spill happened, if you recall, BP had a giant oil spill in the Gulf of Mexico, and we needed to know how big that spill was, how wide the spill was, and how intense. The robot was able to get in the water. It was able to find those plumes of oil and map out exactly the extent of that oil spill.